Hello everyone, myself Professor Deepali Gabudi, and today we are going to discuss about correlation. So what is correlation? Sometimes there occurs a situation where two variables are interconnected. For example, marks and percentage of the students. When the marks are good, the percentage are more good. Second one, the rainfall and agricultural production. If adequate rainfall is there, then the agricultural production is good. And then third one is income and expenditure of a family. So whatever the income, the expenditure is like income. So there is a relation between each in every example there is a relation between the two variables. So such interrelated variables are called correlated variables, and the extent of linear relation between these two variables is called as correlation. And next one is bivariate data. So the data regarding two concerned variables required to determine correlation is called bivariate data. So whenever we are going to determine the correlation between two variables, we need a data. So the data required is called as the bivariate data. Now there are some types of correlation: positive correlation, negative correlation, and no correlation. So what is positive correlation? So when one increase or decrease in one value of one variable is associated with increase or decrease in value of another variable, then correlation between these variables is called as positive correlation. That means the increase or decrease of in value of one variable affects the increase or decrease in value of other variable, then then there is a positive correlation. So there is example of positive correlation, that is marks and percentage of a student shows the positive correlation. If the marks are good, then the percentage will be good. If the marks are poor, then the percentage will be poor. So this is the positive correlation. Next is negative correlation. So here the increase in value of one variable is associated with decrease in value of another variable, or the decrease in value of one variable is associated with the increase in value of other variable. So this correlation is called as negative correlation. So the example is for this: as the price of a good goes up, the quantity demands usually goes down. So when the price of goods is high, the demand will be reduced. So this is the negative correlation. And then no correlation or zero correlation. So when the change in one variable is not related with change in another variable, then the correlation between these variables is called as no or zero correlation. That means when there is no any relation between the value of one variable and the value of other variable, then the relation is called as zero or no correlation. For example, height and marks of students, they are not connected to each other. Height and marks of the student, there is no correlation. So there are some measures of correlation. First one is scatter diagram. So the bivariate data we use for correlation, to show the correlation, it is shown through the scatter diagram. Scatter diagram, so it needs two values, xi and yi. That means two variables. Since there is a correlation between two variables, so we take two values, xi and yi, and the value of I varies from 1 to n. That means we have n number of ordered pairs, xi, yi. So this is the bivariate data on two variables, x and y. If these n pairs are plotted on a graph paper, taking one of the variable on x axis and the other on y axis, we get a diagram, and that diagram is called as scatter diagram. So there are 5 scatter diagrams. So first one is the positive correlation. As the value of one variable increases, the value of other variable also increases. So this is the positive correlation. Then second, and it is the perfect positive correlation because the value increases diagonally. Second one is the perfect negative correlation because as the value of one variable increases, the value of other variable decreases, and it is diagonally decreases. So this is the perfect negative correlation. Next one is negative correlation. Here again we can say that the value of one variable increases but the value of other variable decreases. So this is negative correlation. Second one is positive, last one is fourth one is positive correlation. And last one is no correlation. There is no relation between the value of one variable and the value of another variable. So these are plotted using the values of xi and yi. So xi values are taken on x-axis and the yi values are taken on y-axis. So for example, following table gives the aptitude score and the creativity. So aptitude scores are taken on x-axis and the creativity score taken on y-axis. So this is x-axis and this is the y-axis. The values are taken on x-axis and y-axis. So these are the values of x and these are the values of y. So 63, when the value of x is 63, the value of y is 69. So 63 and 69. So it occurs here. 63 and 69. So this is the value. 63 and 69. When the value is 61, x value is 61, y value is 65. So this is 61 and 65. 62, 67. 62, 67 is this. So likewise, all the points are plotted on this graph. So this is the scatter diagram of given data. Now the next topic is covariance. So what is covariance? The covariance between two variables x and y is denoted by COV of x comma y. Covariance of x comma y, and it is defined as the covariance of x comma y is equal to summation of x minus x bar into y minus y bar upon n. So what is x bar and y bar? X bar and y bar are the arithmetic means of x and y respectively. Here we have given x and y values and we have to find the arithmetic mean of x and y values. So covariance of x comma y is equal to summation of x minus x bar and y minus y bar and divided by total number of values. And the computational formula is covariance of x comma y is equal to summation xy upon n minus x bar into y bar. Next is Karl-Pearson's coefficient of correlation, or in other words it is called as product of moment correlation coefficient. So Karl-Pearson's coefficient of correlation is denoted by R. R. And it is defined as R is equal to summation x minus x bar into y minus y bar upon square root of summation x minus x bar square into summation y minus y bar square. Again, it is simplified as summation xy minus n into x bar y bar divided by square root of summation x square minus nx bar square into summation y square minus ny bar square. Again, it is simplified as 1 upon n into summation xy minus x bar y bar upon sigma x sigma y. So here sigma x and sigma y are the standard deviations of x and y. So using covariance correlation will be r is equal to covariance of x comma y upon sigma x into sigma y. Now there are some properties of correlation coefficient r. So correlation coefficient r lies between the value -1 and +1. That means r -1 less than equal to r less than equal to 1. The value of r correlation coefficient r lies between -1 and +1. If r greater than 0, the correlation is positive correlation. That means the value of r is greater than 0, then the correlation is positive correlation. If r less than 0, then the correlation is negative. If r is equal to 0, then there is no correlation. Again, correlation of x and y is equal to correlation of y comma x. Correlation between x and x is always 1. Correlation between x and -1, x and minus x is equal to -1, and the correlation between x and constant is equal to 0. So these are some properties of correlation coefficient r. So there are some methods of finding correlation coefficient. First one is the direct method, and in direct method there are some steps we have to follow while solving the examples using direct method. So first step is obtain sum of x values, that is summation x, and hence x bar. What is x bar? X bar is the mean of values of x. Again, obtain the sum of y values, that is summation y, and hence y bar. That is the arithmetic mean of y values. Then obtain the sum of squares of x, that is summation x square. Obtain the sum of square y, that is y square, summation y square. Then obtain the sum of products of x and y, that is summation x into y. And find r by applying the formula. So here we have to apply this formula, summation xy minus n into x bar y bar divided by square root of summation x square minus n x bar square into summation y square minus ny bar square. So let us take one example. Here we have given the import of raw material and export of finished products in suitable units. So we have to calculate the coefficient of correlation between the import values and the export values. So these are the import values and these are the export values. Suppose the import values are x and the export values are y. So while finding the correlation, this is the formula, and we need to calculate some values. That means product of x and y, then x bar y bar, then x square and y square summation. So these are the x values, these are the y values. This is x square, this column is for x square, this column is for y square, and this column is for the product of x and y. So here n is equal to 10. That means the number of values of x and y are 10, 10 each. And these are the values of x. So the total is 147. Total is 147. The values of y, the total is 170. Values of x square, and the total is 2291. Values of y square, and the total is 3056. And values of xy, total is 2638. So we can calculate x bar. X bar is the arithmetic mean of x values. So summation x upon n, that is 147 upon 10. 147 upon 10. Here total of x values is 147. Total of y values is 170. x square, summation x square is 2291, summation y square is 3056, and summation xy is 2638. So we can put these values. So here x bar is calculated as 14.7 and y bar, that is summation y upon n, that is 170 upon 10 is equal to 70. Now this is the formula to find correlation. So putting all the values here, summation xy is 2638 minus n is 10, x bar is 14.7 and y bar is 17, divided by summation x square. So summation x square is 2291 minus n into, n means 10 into x bar square, that is 14.7 square, into summation y square. Y square summation is 3056. 3056 minus n is 10 and y bar square, that means 17 square. So after calculating this we will get 139, and after calculating this we will get square root of 130.1, 130.1 into 166, and the final answer is 0.9458, and as the value is greater than 0, so it is the positive correlation. So we can calculate the correlation between the import and export values using this formula. So there is a positive correlation between the import values and the export values. Next one is find the correlation coefficient between x and y, given that n is equal to 25, summation x is equal to 75, summation y is equal to 100, summation x square is equal to 250, summation y square is equal to 500, and summation xy is equal to 325. So in previous example we have calculated all these values. So we have calculated all these values, but in this example already we have given the values, so there is no need to calculate the values again. So here x bar is equal to 75 upon 25, that is 3, and y bar is 100 upon 25, that is equal to 4. Now this is the formula to calculate the correlation coefficient R is equal to summation xy minus n into x bar y bar divided by summation square root of summation x square minus n x bar square into summation y square minus n into y bar square. So putting all the values, now what is summation xy? It is 325, then n is 25, x bar is 3 and y bar is 4. Again under root of summation x square is 250 minus n is 25, x bar square is 3 square, into summation y square is 500 minus n is 25 and y bar square, that means 4 square. So this total is 25 and this is 25 and this is 100. So it is 25 upon square root of 2500, that means this is equal to 25 upon square root of 2500, and this is equal to 25 upon 50, that is 0.5. So the correlation coefficient R is equal to 0.5. Again this is the positive correlation. Second method is deviation method. So again there are some steps we have to follow while solving the example using deviation method. So first we have to obtain the values. We have to calculate some values, that is u is equal to x minus a being a constant. A is the constant. Then calculate the deviation b is equal to y minus b. Again b is the constant. Obtain summation u and summation v. Obtain summation u square and summation v square. Obtain summation uv and then find r by applying the formula. So here we have to apply this formula. Summation uv minus n into u bar v bar upon square root of summation u square minus n into u bar square into summation v square minus n into v bar square. So here u bar is the arithmetic mean of values of u and v bar is the arithmetic mean of values of v. So consider this example. Compare correlation between the heights of father and son from the following data. So here we have given height of father in inches and height of son in inches. So we can take these values as x and y. So let x is equal to height of father and y is equal to height of son. So by deviation method, take u is equal to x minus 60 and v is equal to y minus 65. So these values are taken randomly, 60 and 65. These are the values taken randomly. So these are the values of x. Here total. Here these are the values of y. This is u. U is calculated using this formula, x minus 60. So x minus 60, that means 65 minus 60, that is 5. 65 minus 3, that is 63. 63 minus 60, that is 3, and so on. So these values are calculated using this formula, and this is the value of, these are the values of v. They are calculated using this formula, that is y minus 65. And these are the values of u square. These are the values of v square, and these are the values of u into v. So here summation u is equal to 56, summation v is equal to 24, summation u square is equal to 448, summation v square is equal to 104, and summation uv is equal to 201. These are the values are calculated below. So here u bar is the arithmetic mean of values of u. So summation u upon n. So summation u is 56 divided by 8, that is equal to 7, and summation v bar is equal to v bar is equal to summation v upon n, that is 3. Now this is the formula to calculate the correlation coefficient R. So putting all the values here, summation uv is 201 minus n is 8, u bar is 7, v bar is 3 upon square root of summation u square is 448. Summation u square is 448 minus n, that is 8, into u bar square, that is 7 square, into summation v square is 104. Summation v square is 104 minus n is 8 and v bar square is 3 square. So this total is 33 and this total is 56, this total is 32. So it is 33 upon square root of 56 into 32, that is 0.1378. So this is the correlation coefficient, correlation between the height of father and son. So compute, again the next example is compute the correlation coefficient between x and y, given that. So again here we have given the different values, n summation x minus 35 is equal to 25, summation y minus 19 is equal to 65, summation x minus 35 whole square is equal to 167, summation y minus 19 whole square is equal to 162, and summation x minus 35 into y minus 19 is equal to 130. So let u is equal to x minus 35. X minus 35 and v is equal to y minus 90. Because we have given these values. The values are given in terms of these values. So let u is equal to x minus 35, v is equal to y minus 19, and u bar is equal to u upon n, that is the arithmetic mean of values of u, it is 0.25. Then d bar, that is arithmetic mean of values of v, it is 0.68. So r is calculated using this formula, summation u v minus n into u bar v bar upon square root of summation u square minus n into u bar square into summation v square minus n into v bar square. So putting all the values, we get summation u v, summation u into v. What is u? So summation uv is equal to 130 minus n is 100, u bar is 0.25 and v bar is 0.68, and upon square root of summation u square. Summation u square, that means this 167 minus n is 100 into u bar square. U bar square, that means 0.25 square into summation v square. Now summation v square means this value 162 minus 100, n is 100 into v bar square. V bar is 0.68 whole square. Now this total is 113 and this is square root of 160.75, this value, and the second value is 115 into 76 and the total is 0.8283. So this is the value of r using the different values. Next we have to compute the product moment coefficient of correlation for the following data. Here we have to use the values of sigma x and sigma y, that is the standard deviation of values of x and standard deviation of y. So here we have given n is equal to 100, x bar is equal to 62, y bar is equal to 53. This is the arithmetic mean of values of x, this is the arithmetic mean of values of y. Then standard deviation sigma x given by 10, sigma y is 12, summation x minus x bar into y minus y bar is equal to 8000. So here we have to use the different formula. So r is calculated by summation x minus x bar into y minus y bar upon square root of summation x minus x bar square into summation y minus y bar square. Now we have given the values of sigma x and sigma y, sigma x and sigma y, and the values are calculated. To use sigma x and sigma y, we have to divide the numerator and denominator by n. So here divided by n, again divided by n. So this is square root of summation x minus x bar square upon n is equal to sigma x, and square root of summation y minus y bar whole square upon n is equal to sigma y. That's why we have divided the numerator and denominator by n. So here divided by n, divided by n. So summation x minus x bar into y minus y bar upon n upon sigma x into sigma y. Here, if we take this n in under square root, so here we will get this, and this is sigma x and this is sigma y. So this is sigma x and sigma y. And we have given the value of summation x minus x bar. This is 8,000. 8,000 8,000 divided by 100 upon 10 into 12. So it is 0.6667. 0.6667. So this is the product moment of coefficient of correlation. It is calculated using this formula where we have given the standard deviation of x and y. So this is all about the correlation coefficient, which is calculated using the direct method and deviation method. Using the different formulas, we can calculate the correlation coefficient.